Assalamualaikum everyone. I hope everyone of you is doing well. Okay, so the topic that we are going to discuss today is square numbers. Square numbers and roots. So it's a previously known topic, obviously, and now we are just going to go through it from the very basics, and then we are going to do something new that we haven't done in our previous classes. So starting off with square numbers, we already know square numbers are the numbers if you multiply any number with itself, the product of it is called the squared numbers. So suppose if I multiply 5 with 5 itself, I get 25. So this 25 here is a square number. Now another way of representing this is, instead of writing 5 into 5, we can write it as 5 square, which is again equals to 25, which is a squared number. So this comes in the indices chapter, which we are going to discuss later, but for now I'm just giving you a small intro in this 2 here, which is sitting on top of 5. It's in the subscript. It is written in the subscript in a way that 5 square means 5 multiplied 2 times, right? So if there were 5 to the power 3 or 5 cube, 5 would have been multiplied 3 times. So according to the power, this base will be multiplied that many times. Okay, so any repetitive multiplication can be written like this. So another examples of square numbers maybe are kind of 2 square equals to 4, so 3 square equals to 9. So all these numbers are squared numbers, and for our convenience it is better for us to at least memorize the squared numbers from 1 to 20. It is better because going ahead we are going to need it. Obviously we will be allowed to use our calculators, but for now we need to memorize the squared numbers from 1 to 20. So 1 square equals to 1, 2 square equals to 4, 3 square equals to 9, up to 20. So it's very easy. If you just go through it 2 times, you'll memorize it in no time. Okay, now another concept, that is square roots. Square roots. So what is a square root? It is basically denoted by a radical sign, denoted by the sign. This is a radical sign which is used to denote a square root. Now what is the application of it? The application is, if I square root any squared numbers, it will give us the root of it. What does it mean? Let me show you. Suppose 25 is a square number, right? So 25 is a square number because it is a square of 5. So if I write 25 and if I square root it, it will give me 5. That is basically the application of a square root. So what does a square root gives us? A square root gives us the root of a squared number. What does this root mean? This root means if I multiply 5 2 times, or if I put a square here, it means 5 into 5, which is 25. So basically 5 is the root. If we do some more examples, 36 is another squared numbers, and if we already know 36 is a square of 6. So if we square root it, it will give us the root 6. This root 6 means if I square 6, I'll get 36. So square rooting a squared number gives us the root. So these are basically the roots. Okay, fine. So We already know what square numbers are. Now we know what is a square root is, what is it denoted by, what is its application. Now some problems that we are going to do further regarding this square root is, suppose you will be given a number. Suppose a number 75 and you need to square root it. Now the first thing we need to understand is that we have to realize that, is 75 a squared number? Well, basically it is not a squared number, because from our memorization we know that the square numbers closest to 75 may be less than greater than 75 is 81, which is a squared number, and less than 75 another closest squared number is 64, which is the square of 8. So 75 lies between 64 and 81. So 75, if I write it like this, 75 lies between 81 and 64. 64 and 81 here are squared numbers. So if I want everything to write it in a radical form, so if I put a radical sign over all of it, I know root over 64 is 8, because 64 is a squared number of 8. Basically I don't know the square root of 75, but I do know the square root of 81, which is 9. So root over 75 will definitely fall between 8 and 9, and it will give us a decimal number or a fraction, and not a whole number, definitely, because it is something which is greater than 8 but less than 9. And we know from our previous knowledge that if any number falls between two consecutive whole numbers, it is definitely a decimal number or a fraction. Okay, so this is the first thing that we are going to do for estimating. We will first estimate that square root of 75. If I square root 75, it will give me such a number which will fall between 8 and 9. So this is called estimation. This part is called estimation. Now then the questionnaire will ask you, give us the exact value. So the second part of this question will be, give the value to 2 decimal places. Well, it can vary. The questionnaire may ask you to give the value to 3 decimal places, 4 decimal places, even 1 decimal places. So give the value to 2 decimal places using a calculator, because we cannot find the value of it without using a calculator. And another thing that I missed, that there are certain kind of numbers, if we square root it, it won't give us a whole number or a decimal or a fraction which can be written as a whole, that are called surds. Let me clarify it more to you. If I square root any number, let it be a whole number or a decimal or a fraction, if it does not give me a rational number, those are called surds. Those are also called irrational numbers. Just like 75 does not give me a number which we can say that it's a whole number, or it does not give us a number that we cannot express it as a fraction like a and b. So using our calculator, so for this guys you need to have a scientific calculator. Any basic scientific calculator will go with it. So if you see, so if we square root 75, it gives us a long decimal number, and if you see, it will always give you such kind of a decimal number which is not repetitive. The digits after the decimal does not have a pattern, that it does not repeat itself. it will always give us a new number. So it is a kind of a number which is never ending, which is basically the surds. SURDS, it is called surds. We will learn about it deeply afterward, but for now it will give us something like this. So the questionnaire asked us to give us a value to 2 decimal places. So if we write 8.660, so to do two decimal places means 8.66. We know we don't even need to round it up, because after 6 it was a 0, and we all know how to round up a decimal number. See, if I want to give the answer to 2 decimal places, root over 75 gives us 8.66. So this is the answer. So the first part is estimating. So what we will do, first of all, we will see 75 lies between two squared numbers, the closest one which is greater than it and the closest one which is less than it, and then we will square it, and then after it we know that the square of 64 is 8, the square of 81 is 9. So definitely if I want to square root 75, it will give me such a number which lies between 8 and 9, and after using the calculator we saw that it gave us a number 8.66, which is basically greater than 8 but less than 9. So that is how we estimate and find out the actual answer using a calculator. Okay, now the next part is, if we are given a big number to square root, so that we have to split it. So that is called splitting a squared number. Suppose you have been given a number 1, 2, 2, 5, and you need to square root 8, but without using a calculator. Now if you were to use the calculator, it's just typing it in the calculator and then you get your answers in a second, even less than a second. But if you're not allowed to use the calculator and you have to square root it, and 1225, I don't know if it's a square number or not, but then the method that we are going to use it is splitting it into a factor tree. Split it into a factor tree. So if you see guys, we have come along a new term called factor tree. Factor tree is basically nothing like, we just have to divide it and turn it into a product of its prime factors. Prime factors means, first of all, factors means the numbers which we can divide 1, 2, 2, 5 with exactly. So suppose 1, 2, 2, 5, the last digit is 5, so definitely it is divisible by 5 exactly without any remainder. So 5 is a factor. So let us make us a factor tree. So how do we do it? Just follow the steps. So just without using the radical, just take the number 1, 2, 2, 5. This is also known, this is also called prime factor tree. So you can also add this digit also, add this word also, prime factor tree. Why prime factor tree? Because we want to make it as a product of its prime factors, and prime numbers we already know is a number which is divisible by 1 and the number itself. You will get to know it as we will solve this problem. So 1, 2, 2, 5. So we are going to make it as a tree. So a drop down tree, it's like 1, 2, 2, 5. So the last digit is 5, so definitely it is divisible by 5. So if I divide it by 5, so write the divisor on the left side and write the quotient on the right side. So 1, 2, 2, 5. So if we divide it, you can use your you're not allowed to use your calculator, so you can divide it with a rough work also. So the answer will be 2, 4, 5. Okay, now I have already got a prime number here. See, 5 is a prime number. Why? Because 5 is only divisible by 5 and the number itself, so I don't need to break it up again. because I don't need to divide it by 5 again, because 5 already is a prime number. Now let's break 245. So 245 again is divisible by 245 again is divisible by 5, and the quotient will be 5 4s are 20, 4 plus 5, 5 9s are 45. Now again I have already got a prime factor here 5, so I don't need to break it up. I need to break this 49. So 49 is divisible by 7, and the quotient is 7 7s are 49, so 7. Now 7 also is a prime number because it is only divisible by 1 and 7 itself. So the prime numbers, the prime factors that we have already got is 5, 5, 7 and 7. So if we multiply all this, we will get this number. So I can write 1 2 2 5 as a product of its prime factors. So if we multiply all of this, 5 into 5 into 7 into 7. Okay, but the question was asked to square root it. So if I want to put a square root over it, 1 2 2 5, I will put the square root on all of it. So 5 into 5 into 7 into 7. Now if I want to square root it, now what happens is, if you look very closely, you will see I have a pair of 5 and I have a pair of 7. So if I have a pair of any particular number and there is a square root of it, we can cancel the square root by taking only one factor from here. I'm repeating again, if we have a pair and there is a square root over it, we can cancel the square root by taking one factor from here. So from this pair 5, I'll only